Okay, then I switch it on again. He probably will have to refresh. Could someone tell him on chat that he has to refresh? And when is he with someone? Okay, no, or he just sent a message. Okay.
I'll just mail him, reply to him, after he refreshes.
Yeah, he might probably get a suggestion for a new link, and he should just click that link. Because when I refresh, I see it gives a new link. So from my side is on, and I can see it's live on YouTube. Okay, what was I?
So now all the teachers will be at 2020, right?
There's only one we have.
Oh, we have
one teacher.
Two aspects.
So the teacher has two aspects. Yeah. Now we are going to change a bit of the color statement. Let's see how we say color, but it's now RGB. Yeah, color is red, green, blue, so RGB. And let's say 125, 125, 125. Yeah. So it's red, green, and blue. Let's draw it. Gray, everybody has gray. But this is not what we want. We want to make it transparent so that we can see the previous aspect also. So in RGB, you have a fourth argument, comma, and if you want it to be opaque, you know opaque?
Yes.
Yeah, is 1. But we don't want it opaque, we want it transparent, so we say 0.2 or something else. But between 0 and 1.
0 is transparent and 1
Yeah.
is completely.
Yeah. So let's draw now. Yeah? So we see both the aspects, both the blue square and this gray circle. Of course, it doesn't have to be 125, 125, it can be any RGB.
And that is like a general way to make color, those three arguments?
Hello? Yes, no, all right?
Yeah.
A new student?
No, I took it's my girlfriend, but she hasn't been to Eindhoven yet, so I figured.
But she knows that there is a fee for the course.
You write that on the forum of Gamma.
No, she has to sit through, that is the fee. Okay, welcome. We will start your session maybe 1:15.
Yeah, that's fine.
Okay. Everybody has that transparency?
Yes.
Yes. Now we are going to do some more magic to impress him and the girlfriend. Yes, now we don't draw the circle anymore for the students. We draw a sphere. Size 5. Yeah? What is a sphere? Like a 3D4 circle, sort of. And let's also change Auke. Let's make him a cube. Cube. Yeah? Everybody yes? So now are we 2D or 3D?
2D.
A cube is a 3D or a 2D?
With Java to.
No, I'm just asking if a cube is. So we have to change. We have to change the display.
Oh.
We say OpenGL.
Oh no, Java 3D.
Uh,
No, just joking. Just say it.
OpenGL. Yeah. Instead of Java 2D, you say OpenGL. Yes, no, all right. Yes. So let's begin the game. Yeah? Everybody has it?
Yeah.
Do you see a sphere? No? Did I hear a no?
I see what you see.
Okay.
I see space.
Okay, now let's do the magic. Eh? How many of you have the mouse? No mouse? Okay, let me just show you the magic here. Can you see on the screen? Do you see a sphere?
How do you do that?
That's a paid course. Well, I'm not so sure of Windows. Maybe you can say what's the shortcut?
I don't know if without mouse, I just know with the mouse is the.
Okay, if you have the mouse, you click a single click and the control and the mouse.
Or no. Mouse button is the middle mouse button is alternative for control.
Ah, okay.
Yes, for you is command. Because control is command. Happy. What's for you? Yeah, what's the shot for you? Okay, select and drag. For everyone? Works? Yeah? So it works. Now, does it excite you to do more models? Let's do something more. We have 10 minutes. You will not get this in 2D. Yeah, so remember to change the type of display to OpenGL. Now, while we are still here, let's see what buttons we have in the display. Zoom in, zoom out on the right. And sometimes when you are running a simulation, you also run out of memory because it's a huge display. And you can pause the display, but the simulation is going on. So for example, if you have a simulation where it's changing colors a lot, location is changing, and then if you keep drawing, then the memory, you have a short of memory. Yeah. So you can pause the display and then zoom in, zoom out. And in the end, you have a camera, that's the snapshot. Let's take a picture. It's not a selfie, it's a selfie of the model. Just click it. And now you go to your navigator. On the left navigator. Go to models. It was in documentation, yeah? Documentation, snapshots.
But it's also in models.
Yeah, I think
It's in models.
you have it.
Yeah.
I don't have it. Can anyone help me? No, it's fine. Okay, you can see a picture, right?
Yeah.
So that's how when you are running a simulation and you don't want to do a screenshot, you can do a gamma shot, snapshot, yeah? Okay, and now let's look at something more interesting than the 3D. You see the button here, like a door to the left. This one. Let me back.
Yeah.
What is it called?
It's called layers.
All layers.
Okay, you can just look on screen for now, and I will show you how in different versions it works. So you have this one here on the left top, and here you have like a Photoshop kind of eye. So if you close it, it becomes invisible. So I am making the student invisible, visible, invisible. Yeah. It also works in 2D. Teacher, visible, invisible. And the second aspect of the teacher was this big circle, on, off, on, off. So if you can also switch on and off and then take a snapshot if it's too crowded. Yeah. And now you see the next one. It's showing you that it will open something to the bottom. So let's open it. Is the coordinates of your world. So if you move your mouse, you can see the coordinates changing. Yeah? At least everybody can see on screen, yeah? So we close it. We close the layers. Okay? The next one, it's got something like people, yeah? If you see on screen. So it's the agents and the species. So we have how many species? Yeah. So let's say we go to student. We can browse all of them or any of them. Do you follow? If you open this browse agents, you get a table with all of them. Can everybody see it?
Yeah.
So you have 10 students. So these are 10 students and the indexing starts with 0. Yeah? And within this window, you see a down arrow. So you can download this as an Excel or CSV. So if you have done some calculations and you want to bring it to R, Excel, MATLAB. So let's do it. Yeah? Click the download arrow. It's clicked. I think it should also come into the models. Yeah? Okay. Okay, finally something that doesn't work on Mac. I don't have it here, but you have it. Yeah? Is a CSV or an Excel? Yeah. Now if you click the CSV, it will open within Gamma. Yeah, that's probably you set a default for your system.
Oh no, maybe the old version.
I mean, if you have set your system
Oh.
to have CSVs open in Excel, then it will. And if you want to see in Gamma and you don't want to open another program, you can right-click the CSV and then you say open with. I think is in place of it. Let's start.
But still, it opens in Excel in
System. Defaults in place. Yeah, I think he's in the text. Are the text? Yeah.
But no.
I think that is also your default text editor. But never mind, you can open and have a look within Gamma, that's what I mean to say. You don't have to open many other applications. Yeah? Now a question. How many of you remember the course from yesterday on GIS? Attributes. Yeah? Does it look similar? So if you remember, we added a road, we gave an ID, we gave some other speed limits, and we gave a name for the road. Yeah? It's the same. Now you kind of get an idea how GIS can come in here. If you bring GIS, the table will also look like this. And each feature on your GIS file will be a row, like an ID. Remember we did yesterday? Yeah. Okay, so if later when we do the import for GIS, you can also open and see the attributes. Okay, I want to give time to Martin. So he's blackmailing me with a guest, so I have to give him. Okay, just you're live on YouTube,
Yeah.
just your voice.
Okay.
Yeah.
And could you check again with the microphone?
Yeah, sure.
So we stop asking. Okay?
May I move your laptop, or is it for the YouTube thing? Maybe I can reach.
Oh, careful. It's fine, or you want it more?
No, I think it's fine. Just this needs to reach.
So this is the mic.
Okay. Let's hope today it doesn't. Yeah, works.
It recognizes you now.
Yeah, this time the right way around. So today I'm going to focus more on the model that I made for Myanmar, so specifically the case study that I did for my master thesis, also to show you a bit which other applications, maybe gamma or agent-based modeling, could be used for. Yeah? No. This doesn't work. And there's a lot of text, but basically what I wanted to try to do with my agent-based model is to get an insight in how people move during evacuations over a road network. And the idea was to then get an insight on where you could possibly strengthen your road network in case of an evacuation, which are the points of interest or the critical points during an evacuation. I also tried to look a bit at the communications, but then I couldn't really get that properly into the agent-based model because of time limit and because it had some problems in Myanmar getting data. So first of all, to give you a bit of an impression on what Myanmar looks like and what the case study area looks like, I'm not sure you can fully see it, but on the top left here is an a middle-sized village in the study area in the north of Myanmar. And this is just a nice picture of the train going there. These are the type of houses you could think about. So mostly they're built on poles. So what happens during high water is that they first move themselves into the first floor, up to the first floor. If the water gets higher, or if they expect the water gets higher, then they will still move out of the area to a higher place, to a safer place. And on the top are just some pictures I took during the trip I was there. So first of all, what I started with, which is not much. Actually, the only map that I had before building the agent maze model and before starting the whole study is this one, which is a map of the standing water in 2015. There was a major flood in 2015, and they had some satellite data, which on those days with the data, where is water, not the depths, just where it is. There's also a global inundation model, which is basically a global flood model, which I took some water depth data of, but I changed that later because the resolution was very, very rough. Like one cell of the raster was 1 square kilometer. That was quite a problem. And I derived some flood duration data from my own insight in how long the water is standing there and if evacuations are really necessary. And maybe here around the south, the water can be there for up to 15 days. So yeah, then you don't want to stay in there. Here in the north is mainly mountainous, and then what you get is that the water is maybe there only for 1 day. The problem there is that the water is flowing at a higher velocity, so it's more dangerous if you're currently in that area when there is water. So I also received a map of infrastructure, which was only this. I think it's like 2,400 kilometers of roads, and it's the size of the Netherlands, so of course a lot of roads were missing. So as I already told you yesterday, I had to draw a lot, and drawing in this case means no Google Maps, no OpenStreetMap, because there just simply was no data. So it turned out what I did is just to load a background map, kind of like Google Earth. And I had all the villages, all these points are villages in the study area. And I had to connect them somehow to the road network by just drawing the major roads from what I could see from the actually Google Earth image. So of course, that's already one point of discussion where you come like, how complete is your roadmap? But in this case there was just nothing better. And before building an agent-based model, I think you should always understand a bit like what is happening, like which kind of behavior, which kind of things are you expecting. Because in the end you need to check if your model is running kind of how you expect, if it's running logically. Now this is some stuff I did for my thesis. Basically it comes down to they receive a warning from a government agency, in this case the Department of Meteorology and Hydrology, and then the evacuations are issued by the Relief and Resettlement Department. But the most important part for me was the reasons for evacuation, because people, even though they get a message like you need to evacuate, you need to leave, people don't always want to leave. Things have been seen like that also during Hurricane Katrina, for example, where people just stayed at their home because of their safety of their stuff, or especially people that don't have many things tend to stay in their home because of the resiliency to just build their home again after it's been destroyed. So you kind of stay and protect your stuff, even though of course you cannot protect. That brings me directly. I wanted to go over this quite quickly because I wanted to talk mainly about the model that I built, because it's a gamma session. So the model for me consists of the environment, which are the roads and the flood. So the roads are basically a line network, all connecting to each other, connecting the villages, so the starting points of the people that need to be evacuated. And the flood is something external. I decided not to model the flood in gamma because it takes a lot of calculation time. Instead, I load different shapefiles at a certain run to simulate how this flood is kind of expanding in gamma. And the agents are humans. So the humans, they need to be evacuated. They can be by bus, can be by car, they can even walk. Not advised. And they have several parameters. One of them, of course, is the mode of transport. So is he going by car, is he going by a bus, or is he walking? Another one is something more specific to the model. It's a chance to accept a warning that comes from this kind of getting a message but not wanting to leave. So this is a kind of stochastic variable. For Srirama it might be 80%, and for Auke it might be 20% because he's very stubborn, for example, and he doesn't want to leave. So the model, you can just give a value to this parameter and then it will just stochastically assign this value to each different agent. The same goes for the chance to follow. Some people are very stubborn, they say, I know the way, and they just go, and others, they are a bit less sure about their way, and they tend to have a higher chance of following someone when you're going left, he will also go left. Then there is, again, the chance to accept a warning, and that is a bit of a model thing, which I didn't really do good. I called two things the same as the chance to accept a warning, and in this case it means when somebody turns around because he's seeing a flood, so yeah, you cannot go through it, so you will turn around. Automatically, those people that are going in that direction, maybe the first one will also just go see the flood, turn around. But if you're going during evacuation straight and you see 20 people going back, you're more likely to accept, even though you haven't seen the flood, that the road is blocked. So that in that case, there's this chance to accept this kind of warning from the people going backward, so coming towards you. And this also has to do again with the same kind of idea, like one is more stubborn than the other. And lastly, what's more important is, like I already said, it connotates a knowledge and a beliefs data set. So the knowledge is I've seen the flood and now I turn around. The belief is I haven't seen it, but 20 people are going that way. I just turn around, even though I didn't see if the road was flooded. And the choice to distinguish this kind of data was actually made to see a bit how the communications between people affect evacuations. And another agent is the institution, which is basically just a global agent. It's not on the map, it doesn't do anything. You could possibly give it like certain code that it can block a road for emergency relief or something, but I didn't do that. Basically what for me the institution just does is send the early warning. So you expect high water in a certain area. What in the model is done is it loads a GIS map, a GIS polygon actually. And all the agents inside that polygon are then turned on, like they receive a warning. That doesn't mean they're going to evacuate, that's the chance, but they do receive this warning. Apart from that, I think maybe some specific things about the model is that it focuses on a road network where the roads are represented as graph. That basically means that we can apply a kind of theory to it. It's more mathematical, I think. Also for, I'm not sure, Srirama, do you specifically need a road graph for the driving skill, for the moving skill?
Well, if you want the agent to move on the graph, then you need it.
Yeah. So there's this command as graph. It's not that important, I think, for now. But it kind of makes the agent stick to the road. So if you, for example, say this is an agent and he needs to go here, if you don't do it as graph, he will just go like this. He will go in a straight line. If you make it as graph, he will find a path and follow the path, just like you would do in a real situation on a road. Then I also chose for an abstract representation of agents. What you could probably do is also, what you could for sure do actually, is model a car. Say, I'm in the car and there needs to be a certain distance between me and the next car, and I cannot be inside the next car. But because I was talking about 4 million people, yeah, that was not really a possibility. So what I chose is a more abstract representation, as in a way like we're just moving, and if it's busy on a road, then the speed on that road, so the speed on that link actually is slower. But we can start in the same location, we can move in on the same location, that's not the problem. It's just the speed on the road is determined by the amount of agents or the amount of people on the road. But they can pass each other without hitting, or they can be in the same location. That's also because my agents start in the same place. They all start in a village, and which means it's the same latitude, longitude. So if you, of course, make a code that says you cannot be on top of each other, that for me already was a problem, because I just didn't have the data where the agents would start in the village. So then, specifically for Myanmar, I already mentioned this shortly today. I split the flood event into pluvial and fluvial. Fluvial meaning from the river, pluvial from rainfall. 500 people I set to one agent, because my laptop didn't really like the idea of putting less. I did try to put like 200 people, one agent. It didn't really change the results for me. I figure if I put less, probably it will change the results, but yeah, I couldn't test it. Then the capacity of the roads. I had some background in traffic dynamics. I knew a bit of the roads in the Netherlands, but I took it relatively low for this reason. These are actual roads in Myanmar. During a monsoon, it's near impossible to travel over these roads. As already mentioned, the warnings are sent to predefined areas. So you just load the shapefile and say everybody inside this polygon is warned. And to give a kind of insight, because for me I didn't have any data, so then building an agent-based model and verifying it is very difficult, actually impossible. But what we try to do is, by building different scenarios, by changing these parameters, for example, changing the parameter of following each other, try to get an insight in which behavior you want to stimulate and which behavior you actually want to stop, because it's negative for the evacuation time or negative for the amount of people stuck into the flood. So then it comes to first loading this GIS, so the pre-processing. In the end, I turned out from a very coarse roadmap to a very detailed one with around 19,000 links. So that took 2 weeks. The roads are seen over there. All the black lines are the roads. This is a bit unclear, but all the dots are basically the points where there are villages, so where humans start. And I had the population of the villages, so it's just if there's 1,000 people living in the village, then 2 agents start at that location. If there's 500, then only 1 agent starts at that location. And lastly, I modeled a bit of the flood, because I only had one flood map, like a total one. If you load it into the model, you will just get directly from no flood directly to fully flooded. In reality, it took over 14 days to get the full flood extent. So I cut these maps a bit smaller, made a kind of hydraulic model, not so important. Just to show you a bit of the detail, I zoomed into a small part of the map, which is over here. It's located mainly in the rainfall floods. So you can already get some idea. Like, my computer didn't really like to run this model. Well,
just to say, this many agents, and flood in particular is the most extreme case.
yeah, it's really tough.
So don't feel that you will be having this problem.
It's because of this problem that I described yesterday with the rasters. So loading rasters takes a lot of time. It's that reason that I decided to convert my flood to polygons, but that means having over 20,000 polygons. So yeah, that takes a lot of RAM, takes a lot of memory. Each agent is looking around if there's a polygon of flood. Yeah, basically that. So that's also the reason why for the full model video software didn't work, unfortunately. But I do have videos of the micro behavior. So basically the basic behavior which each agent can do, and then you put them together and it creates this complex system where actually you cannot tell which agent is doing what. So first, starting off, you receive a warning and you decide, I'm going to evacuate or I'm going to stay. This is already the first kind of reflex it runs. Either I'm going to evacuate, if I'm staying, I'm not doing anything. I'm waiting until I receive another another warning, or I'm seeing a flood or whatever. Then what is also affected is the amount of neighbors evacuating. For example, I'm staying put, but my neighbor is leaving, my neighbor on the right is also leaving. It's more probable for me also to leave. Like this, it's basically just a chance. Is it working?
Yeah, you go on.
Okay. It's basically just a chance that's increasing by the amount of people around you that are leaving. Your chance to leave is higher. As soon as you decide to evacuate, you need to know a path. You need to calculate a path from here. I need to go, for example, to the corner over there, and I can only follow the roads. Then maybe this is the shortest path, or maybe this is shorter. So that's basically what it does. Well, that already brought me to one problem in the study area. There's a big river through it, but there's only one bridge, which is completely in the south of the area. So what happens is that agent A in the blue dot over here needs to go to here because it's the closest. I didn't test it for on the road closest, but through the air basically. Reason for that was computational. Like it takes a lot of time for each agent to determine the path to everywhere using a kind of Dijkstra algorithm. So I decided, okay, first you check which is the shelter closest to me, not on the road but through the air. So it goes from A to here. Then I decided, okay, then the agent will go all the way over here. So that's a bit of an extra time. So draw a line between A and I think it's B, and see if it crosses a river. If it crosses a river, okay, you don't go there because of this kind of bridge that's only in the south of the study area. Then you go to the next shelter. So you loop over all the shelters. Again, you cross a river, so you don't go there. Go from A to D, you don't cross the river by drawing this line, and you decide, okay, I'm going here. What you could normally do is just determine the path from A to all the other shelters, but that takes a lot of time because there are many agents, many people, many shelters also, so that was the reason why I had to kind of work around this. I copied the code for it. Basically, this one is not so interesting, I think. Maybe the next one is more. And this one just shows the basic movement. If the agent starts here and he needs to go over here, he will just follow the shortest path. He will just go. He will just follow the shortest path basically. And that code is very, very simple. It's basically only this line, where you follow a path between on the road graph, so on the roads, between yourself, which is for me called nearest node, and the shelter. With weights means that when you load the road, it only loads them as a kind of network with length 1. So you need to make the weights of the length as well in gamma. Am I saying it correctly, or does it load the lengths as well?
Well, the default weight is the length of the segment.
Okay. Yeah, okay. Then I remember why I did this. Because I decided to calculate the speed of the link.
So basically, longer the length, more the time.
Yeah. But for me, I decided to change the weights and also take into account the speed on that link, so that the agent doesn't have a speed, but the road basically has a speed that the agents can travel on. So that's why I did this with weights. Then you come to speed. What I decided, and what I shortly explained yesterday, is that when agents pile up, so basically a traffic jam occurs, because of this abstract kind of showing of the agents, the traffic jam won't show in your screen, but agents will move very, very slowly. So what I decided is, what you would also do in real life, if you're in a traffic jam and at one point you think, okay, this is taking way too long, you might turn around. Maybe not on a highway, but the roads in Myanmar are fair for turning around. They're just small roads. So that also shows in here, where a lot of agents start in this one, they move, and over here there's a link where there will be a traffic jam, and people decide, okay, now another road is going faster, they think. They don't know for sure, because they don't know the speed on these links, only on the first part. But yeah, they decide, maybe I'm taking my chance and I'm just turning around. Now that already created the first problem of writing a lot of code and testing a lot of code, and sometimes it works, sometimes it doesn't work. Then for following, I had to tweak the code a little bit, because normally you would go to the nearest shelter, which are the red dots. So all of them, agents are starting here, agents are starting here, they would all go over here. But I changed the code a bit so that the agents that start here, go over here, the agents that start here, go over here. And the idea for that was that you can show, okay, at one point, when the agents meet over here, they decide, hey, you're going a faster way, or a lot of people are going this way, I'm going to decide to follow you. And I'm going to decide to follow you because your way is shorter. And this was a kind of representation thing, of course, because in reality you won't know if someone's path is shorter to the end. But what you can, oh, that was really quick. Yeah, what you can see is that one agent is very stubborn and he just goes over there. And all the other agents, they decide, once they're in here, to follow the agents that they meet. See, there are a lot of people going right in this case. I will also go right. This, of course, already created the problem. How do you do this? Because I might follow you, you might follow me, we get stuck and we don't go anywhere. So first of all, you look around. That's basically what the code does. It looks around all the other agents, sees which direction they are going. In a way, like I see 20 people and they're all going on one road. Then I'm going to decide to follow. And then I need to determine who is the front agent. So basically what I did is who is closest to the path. In reality you wouldn't do that, and I think there are also better ways in Gamma to do it. But because I decided to load my roads as two-way, so not one link only going this way, one link only going this way, but one link that's going both ways, I had this kind of representation problem. Because you also get the problem that if I'm going that way and let's say I'm in the traffic jam to the corner and you're turning around, you have the same speed as me, even though the way is clear. And that's a bit of the negative, the downside of not loading a directed graph. As already said, the code for following is a bit buggy. I had a lot of problems with it to determine who is the front agent. Then people are turning around, agents are dying. Suddenly you're following someone, that someone is not there anymore. Yeah, my model crashed. So I had to tweak in a little bit that you stop following for a certain amount of runs when the one you are following is not there anymore. Maybe he reached the shelter, or maybe he got stuck in the flood. It just gave me really a lot of problems. Then lastly, because I've been talking a lot about floods, but I didn't show any floods. Loading the floods and showing them was for me not very easy because of this Rust representation and Gamma not really working together. So what I in the end decided to do is just to color the roads if they are flooded. And I only decided to load points into Gamma, not the full raster, only the points, because I'm not interested in all the floods that are next to the road. Over there I don't really care if my road is over here. So I decided only to load points into the model and then give those points a value, which is the water depth. So basically what you can see, the agent doesn't know that it's flooded, so it will go that way. We'll find a flood, we'll turn around to the next shortest path. It doesn't know that there's a flood here. Finds a flood, turns around, and then follows the last path where there's no water to the shelter. That's basically most of the micro behavior in the model. There's still a bit of a distinction between major and minor floods. Minor floods are below 30 centimeters and they only affect speed. So you can drive through water, but slower. Major floods you turn around because it's too high. You just get stuck. And the warnings, as already mentioned, they come into the beliefs database. So kind of a data set to say, this comes from communication and this comes from actually seeing something. Well, then you can finish your evacuation, and there's 3 ways. Successful is that you reach the shelter, so you're safe. Next one is surrounded. At one point you can become surrounded by the flood, so you cannot reach any shelter, but you're not in immediate danger. There's just water around you. So that's what I would call surrounded. And lastly is flooded, where there's really you're in the water, or at least like a couple of meters next to you is water. The surrounding, you should think that there's maybe no water in the surrounding 5 kilometers, but it's all around you, so you cannot go anywhere, but still you're kind of safe. So that was not a big problem. Well, then of course there are many limitations. One of them is a bit described by the first behavior, is that the bridges are excluded from the model because of this cutting out of the rivers. When I want to go to a shelter, but there's a river in between, even though there would be a bridge, I would say, okay, go to a different shelter. And that's because there was only one bridge in the study area, so it was kind of making a choice for me. It's only aimed at road traffic. Many people in Myanmar are walking. They have a family and they only have one motorbike. Well, 8 don't fit on the motorbike, 4 mostly. So they just walk. So then, of course, you're not really limited to roads, especially in a flat area. But yeah, that was for me not possible to model. And as already mentioned, the roads are undirected, so the speed of me going there is the same as the speed of us going there. Yeah, these are just the scenarios with some parameters. Basically, what shows on your screen is then this. Here the roads are turning yellow, and here the roads are turning red. That means there's actually a traffic jam. So the speed is very low compared to what the speed you would expect on such a road. And apart from that, just some snapshots. There are some graphs like how many people have reached the shelter from the total amount of people. How many people have not reached the shelter and have been flooded from the total amount of people. The same goes over here. Here is actually the end graph with roads that during the evacuation were in a traffic jam where the total time was really, really high. And this is just to show you like what happens when all the agents are moving towards a shelter point. You can see that the agents already forming traffic jams and traffic lines over here. So that brought me to some results, which I will not go over, I think, due to time. But most importantly is that what I found is that the biggest problems are around the shelters, and that's related to the traffic jams. People enter this road and they leave the road at one point at a kind of equilibrium time, so they kind of the road is always in a traffic jam, and this starts to build up from the shelter. So that basically made a conclusion like it's better to put more shelters. In this point, there were only 12 in the whole study area, which was very little. That was one of the conclusions. And one other thing that I found is that as soon as people decide to follow each other, things get up even worse. People take the same road. They don't decide to just switch around anymore. They all decide to take the same road. Then, of course, the speed parameter sets in again, like traffic jam, I'm turning around. But in the end, what I saw is that if you encourage people to follow each other, most people stick to the same road in the model, and therefore traffic jams line up even more than before. So that took more time. The other conclusions are more related to the literature review that I did, not so much to the model and to visiting Myanmar actually. Of course, there's like some discussion, especially on the missing roads and the data of the roads and the data of the inputs. Actually, it's kind of unsure, but the idea was to show that the model actually works for this case, even though some data was actually forced. Another thing is to change the amount of agents, so lower it, but I need a better computer for that. The bridges and the boats. People in Myanmar actually evacuate also by boat, and I didn't take that into account. And of course the empirical data, which is always a problem, I think, for agent-based modeling, because you don't have road, especially for evacuations, you don't have road counts during evacuations. As already mentioned, the most important thing for this model was to show which kind of behavior you could possibly stimulate, and which behavior you wanted to, better don't do this, and to see where actually problems would occur on the roads. Some recommendations are mainly related to very technical aspects of the model or to the input maps. I've been doing some in my free time, but it's Myanmar. Yeah, then that's basically what I had to tell about my master thesis, and I wonder if there are any questions. These are all pictures from the study area. Yeah, what you can see, for example, over here is that the flooding is quite serious. All villages get underwater. Sometimes the rivers get quite wide.
Well, I have two questions.
Yeah.
The first question is you had two kinds of agents, human and institution.
Yeah.
Could you tell us how you created the interaction between them? Because they are working on something where they are drivers.
Yeah.
And there is a battery innovation company or something, a technology company which will change the technology of the battery. So will the people buy new battery cars or do not
Okay.
buy? So how do you draw the relation?
Yeah, for this case, I think for the two agents, the institution and the human, for me it was very simple because I just decided the institution can run a kind of code to determine who gets warned, and then everybody inside this area gets a message by doing an ask statement. So if you're in a species and you're in species A and you want to run a kind of code in species B, you can do ask species B and then run this code, but inside species A. So I think that's also a way maybe you could possibly do this with the batteries. Like you can run one piece of code in, for example, the driver or the people, and run that piece of code, but related to the battery. So related to the technology of the battery. I think that's also what I did for some of the humans, because you had the problem of people looking around.
My idea was basically to let those institutions change some sort of environmental variable. In this case, for example, price of a car. And then when users decide to buy a car or not, they simply look at, so global basically gets a variable that's updated by the manufacturing agent, and every tick the
Yeah,
price is
because
changed.
I think for the environment you also call them, basically you call them species as well in Gamma, no? The environment. Or in my case, I consider the environment the floods and the roads. And you in Gamma they don't make a clear distinguish. Both are just species. So
Yes, so I just meant something that all the species can see. So a variable that's visible, basically that's universally known, like it's been in the news, like it's been at the dealer. So you have one species that changes, let's say, universal variable, and then everybody says, oh, well, that is the case. Then like your institution could give a warning. It's basically the same thing.
Yeah, true.
And then, for example, your agents could wake up in the morning and say, well, what should I do today? And they say, oh, I get a warning. Now I will start
now I will leave. So basically you change something in the environment, and then the agent basically looks at that and sees, oh, this is changed, now this is my reaction.
Yeah, so it's basically subscribed to a certain variable in a way that's looked up as as a reflex, for example.
Yeah.
Should I buy a car or shall I buy a car, whatever. I also
could you tell us how you found help or how you started? What was your first place to ask for help?
The first place to ask for help was definitely the forum.
Yeah.
Especially during like small parts of the code that would just crash, and you could work it back by using a write function. So just write yes or write hello. See in the console, hey, this part is working. Then you write it a few lines low. You say, hey, now I don't see anything in the console. So that means there's a bug between this and this part. Then you could track it down to maybe very basic behavior and just write a very small new model, see if it works then, because then it means it's some interaction in your bigger model. If it doesn't work, then you can just post it on the forum and somebody will take a look at it and answer the question, maybe make it better.
I just want to say it's better to go on forum because there are like 100 people looking at your question. And if you send to him or to me or to there is only one person. I encourage you to put it on forum.
And if somebody answers your question, then the rest of the world can benefit.
Yes.
Yeah. Yeah, because that's also one thing. You can search the forum and see if maybe somebody already asked the question before you. Maybe somebody came across a similar problem. There are more people working on traffic, for example. And yeah, maybe you can benefit from the answers on that question. Maybe you don't even need to ask your own question anymore.
The question I had is that was there any way to validate what you did by comparing it to the last evacuation to see if your data was...
No, unfortunately not. That was the problem. There was no data.
Yeah.
So it's just a flood map. So basically that's also why we decided to do just many scenarios. Run like 20 scenarios and just see the differences.
But the total amount of people who died, for example, could you compare that? If your model
yeah, you
predicts 10 times as much, you know, that you're missing something maybe.
Yeah, that was a bit of the problem. Even that is only from newspapers. There was not really any like specific set of data available. I only knew like, okay, in this village there were 12 people dead, in this village there were 10 people dead. No reasons why, just that they were dead. I think if you have the data, you could definitely compare that and also tweak it down, tweak it up a bit by changing some of your parameters.
And you talked about beliefs,
Yeah.
that you stored in separate
Yeah.
database or something. I didn't exactly get, where did you get those beliefs? Why did you store them in a separate database? Why not generate a belief when you initiated the agent or something?
Yeah, it basically comes down from when I wanted to start. I wanted to start with a kind of, I think maybe Srirama knows, a BDI agent, so beliefs, desires, intention agent. But they're very complex.
Yeah.
But the idea is basically the same, that the beliefs part was just to see which influence communications had on one agent, and then in general, of course. And the knowledge was more like I've seen something, so then I act. So that was for me very important because I wanted to split communication, so something you haven't seen but you still act because of it, and something you have seen and then you act.
Yeah, I find them very complex. Also, a lot of people are interested in them. What would you advise people to do? Go for the BDI. There's also a BDI add-in, I think, for Gamma.
Yeah, I haven't used the BDI add-ins.
Yeah, it's still under development, and there's a PhD student working with Patrick, and I think it should be available with the release, stable release this year.
But how happy were you with it? Because to be very honest, when I read about AMS models, usually it's task-oriented more, like they have those behaviors.
Yeah.
I think it's pretty simple, actually. And then you start about BDI, and I'm well, like, okay, I sort of...
It starts getting more vague, yeah.
Is something knowledge, is something a belief?
It
sounds very, very, very complex.
Yeah, I would say don't use it unless you really, really need to.
Yeah.
For me, it was also, I didn't fully implement anything like BDI because it just takes a lot of time and it takes a lot of understanding of BDI agents. For me, it was just the general idea of splitting up a beliefs and a knowledge data set. But normally, I would say don't start with BDI
but if
agents.
You wouldn't start with BDI, could you then give the beliefs simply make the variable that you generate when you start, for example?
Yeah, you could, for example, in my case, what I did is just add a list, actually. Like a list of roads that you think are flooded. So basically, it's just a data set with roads in that case. And then afterwards, you can read them and you can say, okay, these roads are flooded because of communication. You think they are flooded. And these are because you've seen they're flooded.
Okay.
So you could just basically make a simple list or a matrix or something.
And one thing that I didn't understand, you say I use roads that went both ways, not one lane for one way,
Yeah.
one lane for the other way. And one of the disadvantages was that then there would be a traffic jam in both directions. But the roads you modeled were usually pretty small roads,
Yeah.
isn't it? So is it
Yeah,
then that if there's a traffic jam in one direction, it automatically means there's traffic jam in another direction?
Yeah.
Or not?
Yeah, that's basically what it means by modeling an undirected graph. So that means one link. People going that way travel the same speed as people going that
But
way.
then
For small roads, it's fine. Yeah.
Okay, for small it's actually quite realistic. I would think.
Yeah.
No.
Yeah.
But
But there are some bigger roads, and then
Okay. Anybody else? Come on, some intelligent questions from intelligent students. We're looking to find out intelligent right now.
Gamma questions, modeling questions.
No? Okay. Well, in that case, thank you very much.
No problem.
Thank you, Manu.
You did very well. I hope this went well, and I can give. Yeah, thank you. Maybe.
Yeah, I would say like a few more.
Does everybody have lunch or something? We started at 11, and it's now 3. Or 2. So, maybe lunch break or not? Well,
Break for
I have
15 minutes,
a
yeah?
lunch,
Yeah, maybe 15 minutes. 2:15, we'll be back. Yeah. Okay.
Okay. Did you have something you can do?
Yeah, I have.
Give you a stick.
Yeah.
Put it on there. You can also put a movie in the light.
I'm going to explore the city of Eindhoven.
It's not gonna stop.
Okay. If you wait 5 minutes, I can give you your presentation.
Ah, okay.
Maybe it's nice to do back or something. There's a little bit at the start, a little bit at the end, probably. But
Sure.
you know how it went, and you can always send the report, etc., but then something comes in between and splits me.
Yeah, that's true.
And afterwards, there's something you're not interested in anymore because it's so old. Not this one.
Yeah, that was a bit of the problem also during
this section, for example, a lot of models I work with in traffic, it's about biomass, for example. That's all kind of very easily validated models about how this will grow. I will just say, but are you sure that you can prevent, for example, a farmer in Indonesia,
Okay.
from cutting down forest if somebody else also wants palm oil? Yeah, well, we have only palm oil plantations that are really, really strictly yeah, but okay, that's now
Okay.
there's more.
Sorry, we are online.
Okay.
Okay. I'm going to flee into the city.
We have to stop.
You coming back or?
I'm not completely sure.
Okay.
So when is the workshop?
No, let him fly.
No, I'm just curious. Well, if you want to try Git, we can try some other day.
Yeah, I didn't do anything yesterday yet.
I'll probably put up a video.
Yeah, I got
And
the.
I will try also on Windows.
Yeah, and I think I can follow you backwards afterwards on YouTube.
No, I don't mean today. Later.
Ah, okay. Okay.
Yeah.
And thank you also.
Thank you for coming.
Thank you very much.
Okay, clap for Martin.
Yes.
So we
Enjoy Eindhoven. Maybe you like it very much.
It's kind of like Mohammed.
It's now like an online buddy. We never met. Did you know we never met before?
No, that's true.
We met yesterday.
Yeah, we met yesterday on the workshop.
But they treat each other like they know each other for ages. Apparently that's true through the forum.
On the forum, maybe.
Yes.
Yeah. Srirama is always very active on the forum.
Yes. Although no, I have no stake in it.
No, you're not getting paid.
You should ask money for it.
Yes.
That's the problem.
Okay, see you guys.
Bye bye.
Is it on?
Yeah.
Not yet. You want the image on your screen? There's an out. Oh, okay. Because I was talking because I'm not there yet.
Ah, I thought he came with us. Could someone check YouTube for me if we are online? Okay, anybody knows where Kim is? Shall we start? Okay, let's continue with the model. Everybody back with their mouse and keypads. Let's see. Everybody happy with the colors and the 3Ds? Yeah?
Yes.
Let's
install the program file directory, right?
Huh?
It does not install the program file
No,
directory.
it's just zip file and okay. Let's bring in some motion. Let's bring things in motion. We want the students to move around the teacher. Yeah? Let's do it. So just a quick reminder, if you want attributes of your agent, you define them in kind of a global for the species. Yeah? For example, if you want to give them some color, let's do some color for this student species. I say color. All of them should have green. Yeah? Yes? And color is a RGB variable. So I say RGB. So C is a type of RGB variable. Everybody understands?
Yes.
And I say is green. Let's give another variable to the species student. And I say student ID. What can be a student ID? Can it be a string or a number? Number. So let's say integer. Integer student ID. And we give a number, something random. If you give one value, it will be same for everybody, right? So let's say random 10. But random number is not usually integer, it's a float value. So we have to make this integer. Yeah? Everybody follows? So we are giving a random number, but because random number is float, we make it integer. Yeah? So what should be the color of the agent now?
Green.
Green. Yeah? No? Why? So the aspect, the color is now a variable, and we have to put the variable here. Do you follow? Okay, so we defined color as a variable of the species, which is here, RGBC, and I say is red. And in the aspect, I say take the color of C. Yeah? So if you don't have an RGB for a student, everybody is given the same color. But now we have again given a same color, but we could also give a random color. Do you follow? If you define only in the aspect, everybody gets the same aspect. If you want agents to have individual color, you can have them with the global variable of the species. So let's see why and how they come up. We go run the simulation. On the top, you see agents in the menu. Yeah? Sorry? So if you go to agents and we are in simulation and we are looking at students, browse. Now you see they have a student ID. Can you see the attributes?
Yeah.
We just created a student ID and the variable C. Do you see it? So when you add the variables in the species, you can also see them here. All these green and red things that you see here is to hide or unhide them. Yeah, is like a switch. Clear? So you can add as many variables you want for the species, and each agent gets that variable. Yeah? Let's look again. We run the model. Yeah. Now, sometimes you have something on screen and you want to know what it is. For example, some student. So let's look on screen now. You select right click the agent. It says it's student 0. Yeah. Let's say here is, I can see student 8. So I right click is student 8. And then I say inspect. Then you can see all the variables that you defined for the species. But this display is for agent 8 because we selected agent 8.
But that's the same information you saw in the attributes.
Yeah. Here you can do more things with these actions, but we will not do it now. It's better that you try it later. All I wanted to show is you can select something and inspect its attributes. You don't have to look through all the table and see where agent is. You just select the agent, right click and inspect. Yeah? So you can see every agent has a location, and we defined a location for the teacher. We can also define a location for each student. Yeah? But do not change anything here. It's just to inspect. Okay. Now for you to remember, an important is the X, Y, and Z. Yeah? It starts left top and is displayed what is X, what is Y, and what is Z. Yeah? So when you give some locations, be careful of what is X, Y, and Z.
So is your world now 100 by 100 by 100?
Yes. The default world is 100 by 100. Let's see. We gave a random number to student ID. Let's see if they have a random number. Again, we go to this. You have two options. Either you go to the agents menu or you click this short menu here. Let's do it via the agents. In my simulation, students, browse. I can switch off all of them except student ID. You see a random number. Yeah? We did not give them manually to each of them, just a random number. Similarly, you can do it if float, you do a float variable. Yeah? Now, let's say we give the student ability to move. Yeah? So we give skills. The ability is skills. And we give a skill in brackets, square brackets. Yes?
Yes.
Now, you have to tell how they move. So there are two options. Either they move in straight line, Euclidean space, or they move on a network. But now we do not have a network, so we just move them in Euclidean space. Yeah? But again, you don't, for small experiments, you don't want to be very specific. So we have something like a verb called, okay, let's first do a reflex. I will tell you what it is, reflex. So this is an object and we have to give a name. students moving. Yeah? And the brackets, the block. Yeah? And what is the reflex?
Simulating continuous. Is it in that?
Yeah.
If you do it
Yeah, it just keeps going on and on and on.
every tick.
Yeah, every tick. You have to use the right words so that you can look in the documentation. Yeah? It's every cycle.
Cycle.
Yeah? So the students will move every cycle. And I say do. Yeah? Wonder. Who knows wonder?
Just random.
Just random. That's all we want for now. Yes? Let's see. Don't just start the simulation and don't play it. I will show you how to look step by step. You see them? You use this one. This is step by step. They're just moving like they don't know where to go. Any random location. Yes? And if you play, yeah? And on screen, if you see, I'm going to reduce the speed of the simulation. Yeah? I can increase it. Yes? Okay. And how many cycles are done now?
80,155
Yeah. So for each cycle, they have been moving by a certain distance. So if
They only move two-dimensional.
yeah, there's also moving 3D, but we are not doing it now. You can explore yourself. Let's see. Now we say do wander, and I think they were moving very slowly, so I give them a speed. By default is all SI units, standard imperial units. I say they move at 50 kilometer an hour. Yeah, but speed can be a float value. So 50.5 is not. You see, if I say 50, you get a warning. Do you see on the left?
Yeah.
And if you click the warning, it says
I don't get one.
Yeah, I don't know.
no. You have to first put the colon to end the statement. Okay, never mind. Maybe it's an old version you are using. Doesn't matter, just if you look on the screen, if I say 50, it gives me a warning, I can fix it. Yeah? Again, another indicator, if you have 50 and is a warning, if you look on the top of this tab, the yellow, so it tells you your model has a warning. Now notice that one becomes green when I correct the warning. Yeah? So that's an indication for you to see there's still some warning in your model. If it's an error, you will have red. See?
Yeah.
Okay, now we have given a speed. Now let's see. Step by step, but now they are moving much far distances. Yeah? Right? Now you don't want them to wander, but you want them to go to a specific location. Yeah? So we say do, let's keep the speed, or let's also remove the speed. I say do, go to, yeah? Target, and I say I want them to go to the teacher. Yeah? And what is the location of the teacher? 2020. Yes?
You cannot tell them to go to a teacher. You have
We can do it, but it's a bit complex. It's still not in the flow of the lecture. If you remember, Martin was telling you can use the ask statements. So you can ask teacher's location and put it as a variable. Now let's run it. Go step by step. Now you see everybody is going to the teacher.
Yeah.
Yes? Everyone? Yeah. It's very similar. It doesn't matter if you put a network. Suppose you had a network. Then you say do go to target. And here comes another facet, you call it, on a graph. Something. It will have a name. So then they are moving on that graph.
But
Yeah?
they are moving slower. How does it gain even speed?
Yeah, you can give a different speed and they are. Yes? So we know what is a reflex. Now let's see and understand how reflex works. And one of the more something important for you to debug your model. You know what is a debug? To find where the problem is. There is a statement write. Yeah. For every step, we want to write something onto the screen, the console. We say self, which is the agent itself, dot location. Just an example. Yeah. And this is happening every reflex. So every step you will get a new location of all the agents. Let's go to the console. I just double click the console tab so it becomes bigger because we are interested in looking at this one. Yeah? I say step 1. You see? So it's 10 agents and their X, Y, and Z. Okay? Now if you go next step, again there are new locations. And again there are new locations. So the reflex is running every step. Now if you want for just one of them, how do you do it?
You click on the right click on the student.
No, I mean with the code. You want to print, let's say, student. Was the species student or? Yeah. Let's say we want to write for the third student. Dot location. Yes? So we have students and I'm saying give me the location of the third student. Is it the third student?
We're number 3.
Is the fourth student?
Yeah.
Oh.
Because we're starting 0. Be very careful. Let's see what happens now. We go to console. What do we see? The same location
Why do you see some?
because it's being run for each agent. Let's see. That's what I wanted to show. This reflex is inside student. Yeah. Oop, I have a very small screen. So the reflex is for every student, every agent.
And you said student 3
Yeah.
and
I see there are
Yeah.
two values, right? I see it gives me 2 values. I have to check because there are two. This is one value and this is second value. Do you get it?
Oh, so all these values are for student 3 alone.
Yeah.
Should have been, but I see there is some mistake. It should have been the same. Because we asked the location of only one student.
Yeah.
But I see there are two kinds of values.
Yeah.
This is one set of value and this is another set of value.
Yeah.
Seems to be a problem, but just to see how to print the variables. And the reflex is valid to each agent. Now if you do the same thing in teacher, it's only one agent, so the output will only be one. Let's quickly do it. So if you want to remove temporarily a statement, you just comment it. Yeah. Let's go to teacher. Oh, we don't have a reflex. Never mind. We can also write it here, right? In the initialization, write self dot location. Yeah. What do you see on console?
The location of the teacher.
And we did not do any steps, eh? Does everyone follow?
Yes.
Because we put it in the initialization, you don't have to run. You follow?
Yeah.
And it's print, because we have only one agent, it's printed once. You can also have this in global here, and you say write. So whenever you want to ask something to the system, you're not sure, you want to check what's happening, what is the value of this variable, that variable, what is the location, you just say write. Write. Or you can also just write the string. This is where it is initialized. Yeah. Do you see it? Did you write something? You can see it? But we have the text below the species, while we wrote the text above the species. We wrote the text in global, right? So why is it next or later to the species?
For me, it's
For me, it's above.
Hmm?
For me, it's above.
yeah, for me too.
Really?
This is where it is initialized this the first time.
Yeah.
It's the other way around.
And others?
Yeah, here.
Second or on the top? Now where do you have your global statement?
No.
Below.
Yeah, I have it above. You have it above.
This is, I mean, he has it below.
Yeah. Okay, then is a version issue.
No, but yours is which version? This is below.
Yeah.
Oh, sorry.
That's because you are creating the student before you writing the statement. And when you create the student, or teacher, because we have the statement in teacher, it immediately goes to teacher and is initialized. And when teacher is initialized, you already print the right statement. Yeah? You follow the sequence? It's very important. Sometimes you asking a value without initializing it and then you get an error that no such value exists. Yeah? Now let's do a little bit more fun. We go to the model library. But you understand how reflex works. It's different in global, it's different in species. And the sequence it follows is how you initialized the species and the world. Yeah?
So you could just in global type write before create,
Yes.
and then it's the other way around.
Yeah. Now let's go to model library or library models. Features. I cannot promise for the old versions, but for the new ones, let's do data import. You see data importation?
Yeah.
So in this folder you have examples of how to import data from different files, CSV, Excel, shapefiles. Similarly, you see the names are already telling you what they do. How to use a database, how to use date and time. So there are a lot of examples within this project. How to work on graphs, how to initialize actions, maps, multi-level, yeah, this is a bit higher, so we leave it for now. How to use the save statement. So when you did some analysis, you want to save your results. Let's just expand this one. Do you see? If you want to save to a shapefile, you can just go to this model and see how it's where the syntax is, and you can use it. Save to CSV, save to a grid, save to image, save to geotiff, save to text. Yeah. So this is the first place you should look for sample snippets. You can just copy them, change your objects. So for example, in our case, we say we want to save teacher and students. So just change those teacher students from that objects. Yeah. And then if you want to do statistics, there are some examples. And these spatial operators. Remember we were discussing yesterday how far is a building, or how many charging points are within 1 kilometer, 10 kilometer, something like this. So these are all spatial operations. And you have this one. You can look into this folder. And then if you have problems with the correct syntax, there's a whole library how to write the correct syntax. Do you see here? And let's just open one of them. So how casting, you know what is casting?
No.
For example, we had a random number which was a float, but we casted it as integer. Yeah, so you're giving a role to something else, like you have film casting and actors in television, movies. So we had a float and we casted it as integer. So you can interchange many of the variables, and there are a lot of examples there. Let's see the syntax. Syntax.gamal. Yeah. And there you have how to write equations, how to declare attributes, units, meters, kilometers, seconds, hours, how to create actions. Action is a function. Huh?
Cross against the syntax.
No, because it's an old syntax. I told you that if it's not updated to the current syntax, you will have a... Yeah? How to deal with variables, maybe for Laura, who, if you haven't had any programming, you can look at this file, how to deal with variables, integers, species, lists, agents. Okay, Let's do something simple. Coming back to the student teacher example, I created something this morning in the train. Let's have a look. It's very simple. You again have teacher and student. I make the teacher blue. And I have a student, I have them orange. I draw student as a sphere, give them a name. And in experiment, I display their aspects. It's very simple. Now what I changed here is a reflex. We know what is a reflex. I want to collect students at a distance from the teacher. Yeah? Just a basic question. So I say make a list of students at a certain distance, within certain distance. So the statement goes agents, let me make it bigger. Can you see it?
Yeah.
Agents at distance 50. And by default is all meters, kilometers. No, meters is SI units, so it's meters. And time is always in seconds. So 50 meters from the teacher, because we are calling it from the teacher. Yeah. And I then say make it a list. List is a type of variable. So it's not just one, it's a list. I say student list, S list, you can name it as you like, within 50, and then write the names in the list. This is just a text, and this is a variable. So this is just to make some text on screen, string. When it prints, it will say agents at distance, and it will print this list. Let's see. And because we have it in reflex, it's not here. If it was in initialize, it would be here. Because it's in reflex, we have to do one step. Yeah, because reflex is applicable only per step or a cycle. So agents at distance, student 3 is within 50 meters. Yeah. Now because similarly, if we look at the other statements, I'm now taking just one student, yeah, and it's not a regular integer float list color, but the variable type is student. So if you have a species, you can have a variable by that species. Yes? So if you have a species, you can have a variable of that species. So I am saying just one is a variable of the student. And here that we had a list of students, now it's just one student. That's the difference I want you to understand. So I say, again is right natural language. Student closest to self. And who is the self here? The teacher. So this statement gives me student, just one student, who is the most closest in space to the teacher. And I make it a variable of student because what it returns is a student. And I say closest student is the variable. Yeah, let's see. We have to do one step because it's in reflex. Closest student is student 0. You have 2 in the list, but closest is 0. You follow the difference?
Yeah.
Let's have a look. This is the closest one, 0, but within 50 probably is also another one. Yeah? So in the list you have 2. Yeah, and the closest is 1. Now let's see what is this gray circle. I just drew something for 30. Can you see here?
No.
Like we drew before. It has nothing to do who is closest or who is first. And again is RGB and the transparency value. And now it's changed because we did not give a location like we did in the previous example. And let's see what happens now. We have to do a step. There's one agent and closest is also 0. And this is his distance. Now let's look at that statement. Here, because distance is a float, you have to learn to give your variable an appropriate name, otherwise you will get confused. So here I'm saying distance to student, and the distance to the closest student. And who is the closest student? Just one. Yeah. So I say just one, distance to self. Yeah. So it gives me a float value because it's a distance, and then I write it. So I say closest student is at a distance to student. Yeah. Now let's do this. We have teacher here, again random location. We go one step. We get all these three calculations we requested. Now we have more students. Do you notice? Agents at a 50-meter distance are 4 now. Basically all 4 of them. And then the closest is 0. I think he likes the 0. It's always the same. And the closest student is at its particular distance. You can use this for distance calculations. If you say you will find out the distance, let's say this one is 29, and you could have a condition, if somebody is more than 20 meters, I want to ignore them. Yeah. Then you need a value, and this is how you get the value. Or if you say something is less than 30, I accept. Yeah. Now when you are learning, I would always advise, unless you have fixed the locations, always try to learn with this refresh. Yeah, now it's changed. And it helps you learn what's happening in the model. Now it's different. Now you have only 2 students. Again you refresh, you have a different configuration. Yeah. This sometimes helps in debugging. Okay. Now let's see something else. This is another model. Yeah, just some squares. We created squares in the morning. Again, the moving skills. It's too slow, right?
Yeah.
Because I decrease. Now I increase. I decrease. I increase. Remember, we did an example that everybody should go to the teacher.
Yeah.
Something similar.
Yeah.
Okay. It's 3 o'clock. So I hope you have an understanding of the structure and some keywords. Now we look at some made tutorials already. Yeah?
Yeah.
Because now you somehow know the terminology. And I will show you how to explore the model library, and you can mostly find all kinds of examples within the library. Let's see. Kim, which was the traffic one you were seeing during the presentation?
I was in toy models.
Okay. So you don't have to do it. Just for you to know, they all exist in the model library. We are going to the toy models. And then, Kim? Traffic. Because you will also be working with cars and their movements.
Simple.
But please remember, ABM is not about only transport. It's just examples here are mostly for transport. It's any kind of agent and their interactions. Because transport is a bit moving, it's nice to see and people show in the examples. ABM has nothing to do with motion or movement. So we look at the simple traffic model. Now questions, quiz. What's the name of the model? Traffic. Yeah? And you see there is a description. Huh? You should also make a habit to write the description. So it says a simple road network. Yeah? There's some description. You should always make it. And then you have initialization, a reflex, species, and within species you have variables, like we created student ID and color. Yeah, so it's point, leaving probability, speed, color. So you have a reflex, you have two of them, and you have an aspect. You have a building species, and the species has an aspect, and then roads, and the road has some attributes and an aspect, and then we have an experiment. Let's first see how it works, and then we go through the model. Yeah? This is coming from shapefiles, which we tried to draw as a basic example, roads and buildings and some people. Now we want, let's reduce the speed, play this, in. Do you see the people here? Yeah, and then we do our tricks that we learned. It's nice to see.
Can we have 3D?
So yeah, this is still 2D.
No, but that's a joke because I know it's easy.
Yeah.
It doesn't matter.
Does everyone follow? How to zoom in and tilt the image? Yeah, let's see at the model. Let's see the model now. I think we could do something to satisfy Auke. You say depth. I think it still exists. Yeah. So I'm giving all the buildings a height of 5 meters.
I'm curious if it works like that.
We'll see.
Would be quite something.
It's just a default, and now the magic begins. Let's reduce the speed. Run. We zoom in, and we tilt, and there we have our height.
There's really no program on earth that makes it so easy to manipulate shapefiles.
Yeah?
Yeah.
Let's stop it.
You can also build into a different.
Now, obviously, this is not a university building to have the same height. It's a city. So, what do we do?
Are you kidding me?
Up to 50 meters.
You shitting me?
Yeah? Some more magic. Okay. Let's make it bigger. Zoom in, and they're all different heights.
City a la carte.
Yeah?
Yeah.
It's fun, eh?
Yeah.
Just one line. Basically one word. Depth.
Yeah.
More interesting. Let's make the people rectangles so that they look like cars. Or cubes, I mean. Let's see, this is circle. We change it. No, rectangle. And how do you specify rectangle? Yeah, it's not a square, so you need 2 dimensions. So usually the car is 5 meters long and 2 meters wide. Although I'm not sure which one is a breadth and a width here. We'll find out. So what will this do? Rectangle. Did we want a rectangle? We also wanted some depth. Let's say 1 meter. Yeah? Now you see they're not aligned to the street. And that's why you should prefer a circle or a square, so you don't have, but that does not mean you cannot do it. We can do it. Another word, just one word. You say direction. I think it still exists in this one, and you give a heading, or I think it's just heading. I have to check, but there's one word, you give heading so that it aligns with the road. Yeah? I'm just checking now, I'm not sure, don't do this. Okay, now I'm confused. What do? I look for help. How do I look for help? I say Control H.
You don't put your arrow, your cursor on that.
Now I'm trying to find a syntax help.
Oh, okay.
So I'm sure there is some model which talks about heading. I say heading. Yep, there are many of them. So here you see they are giving a heading. Heading in technical terms is a direction you are moving in. Yeah? So it is possible, as you can see, draw circle. Can you see it?
Yes.
Of size this one, you can also rotate it. Again, one word, rotate 90 degrees. Give it a heading. You can look into the model and what they define as a heading, but just to give you an idea, you look for heading, search Control H. You can, there's also this rotate. Yeah, that's how you look. I think I'm not going to do it now. I don't remember it, but it's in one of the models. You can do it. Yeah? So as you see, we give a depth and these cars also have a height.
Yeah, actually the model.
Yeah?
It's pretty hard to see all the cars behind all the big buildings now.
Yeah, you think so?
The disadvantages of
So they will tell you how you can make it visible. How do you make it visible?
How do
Do
I
you make it
Transparent. Again, just one word.
not easy.
Yeah? Okay, you know it, and I'm sure you will do it for Auke. So I'm not doing it. Happy? It's really fun if you are interested. You can actually see what's happening, you can debug it.
Yes, I really like this visual debugging.
Yep. Kim, any other model, nice one?
No.
No? One of the most famous ABM models is Predator Prey. And if you have not read this one, I encourage you to read this one. It's like one of the very basic examples people start when they do ABM.
Yeah, the ants and predator prey. Yeah, an ant we already saw.
Yeah.
As Martha shown us.
Ants,
There's one more, I think.
and there's one more.
Some disease or something.
Yeah, we have it here. Look at this one
Sorry?
Yeah.
here. Infections and susceptibility.
I think
This is a very common model. And the other one is urban segregation.
Oh yeah, that's the first one.
That's the first one. Shelling, something. Yeah.
That's the say how. Yeah. But he didn't use a computer.
No.
Use
Here, this one, segregation, you see this one? So basically it's based in, I think, 1960s. This was a scientist, and there was urban segregation based on racism. So white people would not stay with black people, and so if somebody in your neighborhood comes in as a black, and if there are more black people, then you are switching your place to more white people. Yeah? And if white people come in, then black people move away, something. That was one of the first models. You should have a look at it. Maybe we can now. I don't know how it works. Yes, you can read into the definitions, but I'll just run the model. So towards the end, you will see it's very segregated. It was a mix, and now you see all the red people are coming together, all the yellow people are coming together. Yeah? So in short, what this one does is every agent looks within a certain distance and say if I have more than 50% people of another color, I go, we use the go to, I go to a place where there is more my color. Yeah? So when you run this for a long time, you can see it's basically made of reflex. Reflex, migrate. Do you see? That's all it is. If you learn to do reflex and action, action I told you is the same as reflex, but only when you call. But if you call an action in reflex, you follow? You have a reflex, so is every step, every cycle. An action is only when you call it. But you can have an action in a reflex.
So every step it will response you to call it.
I'll tell you. It's just that you don't have to duplicate if you want to do the same function. Like all programming languages, you pass on parameters and you do the same action and return the value.
So, for example,
So
multiple reflexes have the same action.
Basically, in this case, the migrate action is applicable to any color. So species of each color is calling the same migrate function.
Is it migrate function then localized in each different species?
Is in the global, I think. No, it's here. It's in grid. So, and everybody else is calling the grid. Yeah. Everybody follows.
What are entities?
That's old language is not applicable anymore. Basically, species were defined in a block, and the block was called entities. Is it here in this model, or is it some? You're using the old version. Okay. Because now it's not there. Yeah? So these are some very basic examples. If you Google online, best examples for ABM or beginners examples for ABM.
The library is beautiful.
Yeah. And then you can study it online and you can come and you can change the parameters, play around. Okay, let's see. I will show you something similar I did for Rotterdam. And this is from just open source. You can download it. So, this is a very basic example. I will show you first, and then we discuss the model. Anybody recognizes this as Rotterdam? No one? So now we are going to see another trick. Yeah? Now this is a CBD. and is a true, maybe for Auke, is a true depth of the buildings in Rotterdam. It's not randomized. This one. There are certain file formats where you can download all the buildings, especially what you see on Google Earth, the 3D buildings. You can download them, not from Google, but
Any idea if the open source shape files that we have from all the neighborhoods contain that data?
for Rotterdam, every house is available. I'm not sure about Hague.
If Peter doesn't deliver, to complain, right?
And now we are
Neighborhood with heights.
going to Rotterdam Central Station. This one. These are the platforms. You see this string of. Yeah, I have a very small screen, so it's difficult to. You see this? This is a train station. These are. Do you know any name of the building? I think this.
Nationaal Nederlanden?
Yeah, all those. Is a true shape. Yeah, it's not randomized.
But we don't analyze these, right?
No, I know. I was
No,
studying.
Just asking.
Yeah. I was studying the whole city, but I only represent these ones to not have too much load on the model.
But do you analyze sort of a center of gravity of these, like a point?
No,
Do you
not
analyze them as polygons.
No, this is just for people to orient themselves with the model. So I put the river and some the central area. Yeah.
So how did you actually create this? You made polygons.
No, it's available online. I just imported.
There's more and more shape files. So that's the beauty, I think, of this system, this system. There's more and more data simply there. Like roads, rivers, buildings, charge points.
Yep. I will show you something in a moment. Where is?
Usually, if you want to work with that sort of data, that's really hard. But if you can just say everything that I import exists on the same geographical substrate, it's all, a little bit like you said yesterday, like all the layers, it's very easy to connect them once you have different geographical representations on different layers, but you know where they intersect, where they touch. You can say, okay, go to the building, and does the building have a charge point? All that sort of stuff is immediately available.
And that's why I showed them the go-to examples. If you have a specific location, you can just write one line, go to, on the network. We didn't use a network, so we didn't say on the network, but you can say on the network. Now you see here, I have commented a line. Now I make it active. I say species, road, aspect, base. Yeah, we did it until here. Now I add a third facet, position of the layer, and I give it not an X, not a Y, but a Z. Everybody follows? Now let's see what it does. Looks a bit strange, yeah? Why? Because now my roads are at a height.
Why couldn't I see that when it was top down? Is it sort of perspective thing going on?
Sorry?
If you look at it straight from above, why do you still see it? Is there some kind of perspective going on?
Yeah, because it's not a completely flat view. You see it? So sometimes you would. Let's actually do it. We go into future. Kim, which was the model? Traffic? Simple traffic, yeah?
Yeah.
Let's see. Now we have flying cars. You get it, right? People. Let's make them fly. What's the command? Okay? Okay, let's see them flying. Oh, they're already flying. I think it's too high. Let's just one. Well, you get the essence of it. Okay, let's fly them around a bit slower. We have a futuristic city here. Still too high to appreciate.
The way some people say that if you actually fly, or if you use tunnels, Elon Musk is great about tunnels, then you can have people crossing at any altitude basically.
Yeah,
So traffic jams,
no
traffic jams anymore. You just take a higher layer.
Now, I tell you, for those of you who are crazy about designing drones and flying them around, you can use it. Oh, even 0.5 is too high. But you get it, right? Let's just do it for fun and then we close. Doesn't make a real sense.
No.
Yeah, okay. Right? Now let's go to the most famous example. It's called the road traffic. Why are you laughing?
It's not famous. Gamma.
And you see there's also predator-prey. Is one of the most common examples, and that's why you have it in tutorials. And if you want to follow these tutorials, I'll just read through them and explain to you how it goes. But it's all available on the Gamma website, step by step. And I don't want to just repeat myself, you can do at home. So,
Just a couple of tutorials, it becomes like, no.
so you see the model has 7 model files. And if you go online to the Gamma website, each tutorial is 1 model file, and you slowly increase the complexity of the model. Yeah? So model 1 is the most basic one, and model 7 is a complex one. Okay? Let's look at model 1. So Anand,
Yeah.
can you tell me what's happening in global?
Shapefiles are taken
We are importing a shapefile.
yeah, for building land roads.
Now just go step line by line.
Yeah.
And then we import,
Yeah. Then first we import to the building and then the roads.
yeah,
And then
I will tell you what this is.
yeah.
If you remember, the default shape of the world was 100 by 100.
Yeah.
And if you go to a real practical scale, it's no longer 100 meter by 100 meter. So you want to create an envelope.
Okay, so it does.
Yeah. So the boundaries of the building shapefile and the road shapefiles, well, basically you can take the largest extent and say this is my envelope. In this case, they are using both. You can read the tutorials. So basically, it's no longer 100 by 100. We are moving out of theory and now into practice. If you are studying Eindhoven, you say you have a shapefile and say this shapefile is my extent of my model. Yeah. Float, step, and I
What
think
happens when the shapefile is larger than the envelope?
it cannot be, because the envelope is the shapefile, the extent of the shapefile.
But can you also just manually
Sort of cut a part of the shapefile out in Gamma.
No, you will have to do it outside, and then you can manually define a polygon. You say xy, 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 and this is my envelope. But is usually when you're doing practical things, you already have a shapefile and you know the extent. But yes, you can create a polygon and say this is my envelope. So before you define the geometry, you define another geometry with a polygon. And then next you say this geometry in the previous line is my envelope. And float step, this is the most confusing part, and that's why I have been avoiding it. It took me 6 months to get to understand what this is,
Oh.
but now I will explain in 6 minutes. Basically, each simulation step is a default 1 second because it's SI units. But now you are saying here make each step 10 minutes. So when your tick is moving, the duration of one step, one cycle is now 10 minutes. Does everybody get it? Yeah, it's not very clear in documentation, at least when I started.
I didn't know it. That was so easy.
Yeah. So if you do the regular model and you want to analyze 10 years, how many seconds is it? You don't want to do that. Let's say this one is an example of, I think, a day. This is for peak hour, I think, this example. And the people are going to office and again in the evening coming back. That's why they have 10 minutes. But if you are analyzing 40 minutes, 40 years, maybe you want to have 6 months as a step or 1 year as a step. Yeah?
For smart charging, it's always 15 minutes is like the golden rule because now all the smart meters are giving information every quarter hour. It's a kwartierware allocatie, as they call it.
Okay.
So it's now 50 minutes like where most of the grid operators are running.
So you define this step in the global section. So it's applicable to everything in the model. And you cannot do it in any species. It's not accepted by the syntax. So this step is always global.
But if you, for example, want to run a model for 40 years, but you still really would like a higher resolution for some processes, just checking, right? You could theoretically take the step, the smallest step you want, and then, for example, in the species or in reflexes, you could say only do this every 100 steps or something.
Yes.
And then it would still take some resources every step.
Yeah.
But basically, it would stop using resources as soon as it saw, only once in 100, it's not 100 steps.
Yes. I will show. Do you understand the question? Okay.
Because I'm always working with multiple levels and also multiple time levels. For some things you want very small time levels, and I'm still not sure how good it works. But it would be really great if I could have some process.
I will show you an example quickly.
Okay.
You remember this example with student and teachers? We had a reflex, so it's every step. Now I want something that is happening only every 10 steps, example. But that each 10 step could be any duration that you set in the global. Yeah? So I say reflex, print something. So it's an object and a name. And now I say when cycle is more than 10, and the block, right? It could be anything. I'm just making an example here. I am happy. Yeah, I'm not always happy. I am happy only after 10. Yeah? It's still a reflex, but with a condition. And because we are printing, we look at the console. So just, you see it's cycle 1, and there's no happy statement. 2, nothing. 3, nothing. 4, nothing. 5, 6, 7, 8, 9, 10. And we finished 10, and we said more than 10. No, okay, it starts with 0. Yeah. You see? Now I'm happy. You follow the condition that comes with reflex? Yeah, I think the first one is initialization,
Oh,
and then there's 10, and then 11. Now you don't have to do it this way, you can do another way. You can also put this as equal, so it prints only when it's 10, and then from 11 is doesn't do anything. Similarly, you can also say, let's keep it short, every two cycles you do something.
That's what I'm.
I'm not happy. I'm not happy. I'm happy. I'm not happy. I'm happy. Yeah? Not happy, and then you are happy.
Do you have any idea what this does to processing? I mean, how
Yeah,
what is still the load when you run it? And
Yeah,
it's
it
not
depends
used?
how complex is the reflex. It's just a numerical calculation is fine, but it's agent behavior and interactions.
No, but I mean, if you say every 10, whatever, how much does it use the other 9 when it's not run?
I cannot give you a number, but usually if it's only calculations, it doesn't matter. But if you say, okay, every 2 seconds go to that agent, make some calculation, come back, so you are not only using this agent, also that agent doing something there. So there's no direct answer. It depends on your complexity. Yeah. Usually I do this with display.
Yeah.
I don't display every second. I say give me a display every 100 cycles or something. Because visualization is where it takes most RAM. Okay. And you see here we have a warning, because in gamma time can also be a subunit, I mean a decimal float. You can break time into more finer.
How do you do that? I mean, this is a cycle.
Yeah,
So
you
how
can
can
have
you
a
break this?
subcycle. I don't do it, it's too complex even for me, but just because you have a warning, I wanted to show you how.
You have a subcycle, interesting. Because you could do things both ways. I mean, I could have a model that runs on a high resolution and then do every 10.
Yeah, I mean, I do not really, I have not done it, and I
will
cannot.
look, I will look.
Yeah. Okay, let's look at one again. So we get in shape files, we create the buildings, and you say from that shape file, create road from that shape file. Does everyone follow? Yeah? It's simple. Create something from something. And the species, string type, probably you can give a name to the building. And then you have a color, aspect, species, also color. And then you have an experiment, you say display, OpenGL, then you have nice visualizations. But if you are doing high complex things, it's better to use Java. Yeah, this 3D takes a lot of memory. So the first step is just to take in shapefiles and display them. Yeah? Nothing special in step 1. And let's look at the next step. Step 2. And let's do it a bit intelligent. We select model 1, model 2. Yeah, some magic from Gamma again to keep you awake. You select 2 models and you say compare both. So you can see what has changed between the 2 steps. Yeah. Yesterday we saw how to compare the same file with its history. Kim, you know this one, history? I think if you right click a model and you say compare local history, so it gives you the history of the model if you made any changes in time. Now today what we are doing is comparing two of them. Not the same file, but two different files. Yeah? Okay? And if you see, every model has this box called uses. So it tells you what the model is using. So it's using 3 external pieces of information: bounds, buildings. Basically the bounds is the extent, and you have buildings and roads. Now let's see at the last step. So we have a lot of inputs, and we define the envelope, and we say step is 10 minutes, number of people 100. So just pay attention, here is an integer, number of people 100, and then when you create people, number is not a number but a variable. We only did simple stuff where we gave a number, but it can be a variable. Yeah, so we're just calling the variable. And then you have time to go. Kim, this probably makes your project easier. So this says the starting time to work 6 a.m. Maximum time before you, latest time you can go to work is 8 a.m. Work ends 16, latest by 8 p.m. And you have a minimum speed and a maximum speed at which they can travel. And then forget about this one. And then you define a graph. And this graph is coming from the roads, and you take the roads. So this is now an empty graph, and we are going to fill it here, the graph. Yeah, so we create a variable of the kind graph, and we say the graph is the road shapefile. Follow? Yes?
It's still magic. I mean,
Let's look again.
Shapefile, you have one command and it's now an agent, you have another command and say follow it. I mean,
So this is the one, shapefile roads. You import it, you did nothing with it, and then shapefile roads, you say create roads, so you now have agents. And from this roads, you say make a graph for me. You see here? The graph is coming from the road. Don't worry about these things, just to understand how shapefile becomes a graph. And if you remember, shapefile has attributes. Yeah? Let me show you how it comes in. So, for example, buildings is a shapefile. Create buildings from shapefile buildings with. These are the attributes of the shapefile. Let's see. Who is interested now? Sleepy? No. We look into includes. We are looking at buildings. This one? Yes? We don't know where it is. We're going to find it. Start Explorer. Show it to me. Here it is. And now I'm going to open. Okay. Buildings. Yeah? Now, the variable we had here is nature. So we are saying type is a string, read the column nature or the attribute nature. We know how to look at attributes. Right click, open attribute table, nature. Yeah? And
And this is exactly how Peter will also deliver the neighborhoods.
I don't know if he's online or.
I don't know either, but he's still going to do it because we already
Okay.
talked about it.
I don't know. I'm just leaving it alone. But pay attention that nature is all caps. Yeah? Capital letters.
So it's cap sensitive.
If you go to gamma, you see it's capital. If you write small letters, you'll get an error. It's just that easy. You can have 100 attributes in GIS, but you want only nature, you bring only nature.
And all the other attributes are basically, they take a little bit more time to read the file maybe, but that's all.
No, it's not read. It only reads the geometry and only the attributes you ask them to get in.
Okay, so you can have really, really heavy, big shape files, and you can simply let them be. All the other attributes
Yes.
are no bother to you.
No.
You just take up space on your hard drive.
Yeah, I tell you, yesterday, if you remember, I said there are 6 files with a shapefile. This one is a geometry. Yeah. This one is attributes. And combined together is this one. For roads, this is the database file DBF. This is a shape file, and the shapes come from this SHX.
It's all measured in bytes, and you can download tens of gigabytes of information about things in Holland. You can imagine if this is, let's say, 2 kilobytes, how much information there is if there's many, many gigabytes. Well, you know everything about it, of course, okay. You know everything about it, how much shape files we have in Holland. Yeah.
Okay. So we import the shape files. Now, if you create number of people was 100, you give them speed, minimum speed plus some stochasticity, starting work, something plus some random, end work, also similar. And if you looked at this nature, basically what it has is residential or industrial. Yeah, you hear? Obviously, you will have more residences than industries. Again, where is it? Here, industrial, residential. Yeah?
Just if I may, we talked with Gijs van der Poel last Tuesday. He's like an expert on charging stations, etc. He gave us how you model neighborhoods. And he says, well, basically we found that 3 functions are all you need to model a neighborhood quite specifically. Living, working, and visiting. And visiting is like museum, shop, etc., etc., etc. Living is of course homes, and work is like offices, industry, etc., etc. So if you basically give every building those 3 attributes, we can make sure that they are visited and people are using energy there at the right time.
Yeah. So here you are saying residential buildings are buildings where the type defined in shapefile is residential. And this is small letters, if you have noticed. You have to be very careful. Here, these are just the first one is capital and then is small. So the same goes here. Yeah? So you are, from one shapefile, you are making 2 lists. One list of residential buildings, and you put a condition where type is residential, and the second one where type is industrial. Yeah? So you have 2 lists. Now we are making people here, creating people, working place, living place. Now living place, because it's not a very concrete model based on data, is something for you to understand. It says one of the residential buildings. You can also specify an exact building, but because it's just a tutorial, you say living place is one of the many residential buildings. Working place is one of the many industrial.
But then more people can live in one building.
Yeah.
No.
Okay.
What is an object? Nice.
Yeah. So the objective, the default objective is resting. So everybody is at home. And when the clock ticks 6 o'clock, the objective changes to work.
6 o'clock, really?
But I think it's a kind of constant.
Yeah, it will change in the reflex when the time ticks.
So then the reflex changes the global.
Yeah, here this is being initialized. Yeah? The initial state.
It's also a question I had with Peter. When do you initialize stuff in initialize, so to speak? And when do you initialize stuff in the agent itself? Because in the species you
It's
can
both
also
the same.
initialize.
It doesn't matter. Either you define when you create them.
That's so funny.
In both the places, they are initialized when an agent is created. So you can do them up in global or in the species.
Because I feel like it's neat to have it in the agent because then everything relates to the agent.
It's
is
fine.
in the agent.
You can do it.
But there's no rule for that.
Well, it's very detailed. I don't know if you want to go into that detail. Sometimes when you want to define variables before you come down to the agents, so that other agents can access this global, then you define it up there.
That's logical.
Yeah. Okay. We don't want to look into this one, but basically it says a road is damaged and then every cycle you repair it. And here you see the statement reflects repair road when every some step. Yeah. So it's not every step, but some calculation is going on here.
Actually, that could be really interesting for Anand and Laura if you want to go that detail, because the grid basically behaves in the same way. You can overload the grid very easily. You can even overload it to, let's say, 200%, but it starts to degrade really rapidly. If you keep it up, 200%, for example, for, let's say, 2 hours, it will start to melt, and you can basically throw away the whole thing. But so aging is related to how you use it,
Yep.
and this way you can very easily see where things go wrong. So power, I've always found that a lot of load functionality that's built into Gamma could be power grid functionality if you just name it a little bit differently.
Yeah, it's all network structures.
I don't know network stuff. It's above my pay grade question.
Okay. Again, we saw people moving, the skills. Yeah. So here the people are moving. They have a color, and they already live in some buildings. They work in some places. And there is a start time, end time, and string. Yeah, let me just go here. Reflects time to work. So it's an object and its name, time to work. When do you work? When the current hour is start time that you defined here. So every agent has its own starting time, Kim. So it's starting time, and when the objective is resting, you change it to working status. Basically, when you are resting, but the time is to work, you change the objective to working. Does everybody understand? It can be simpler, but is efficient because we are already in model 7. So it's not simpler statements. So you're saying time to work when current hour is your working hour and you're currently resting. Then you say change my state to working because the time is now to work. And the target changes to one of the working places.
And if you wouldn't say objective is resting, I think it would still work, but it would have to do this all the time. And it's
Yeah, it
a
will.
waste of computing power.
Yeah, I mean, it will go nowhere because working is given a target to go to one of the working places. So the
Or any
objective,
location also.
yeah.
We change location every reflex. Yeah.
Yeah. Similarly, time to go home. When the current time is your defined end time, and your current objective is working. So you're working, and you look at your clock. It's time to go home. So your objective changes to resting, and your objective is to go home, and therefore the target is any location in a living place. You can make it specific. It's just random locations here. Now the next one, reflex move. When in programming language, when you have this exclamation, it means not. Yeah. So this is equal to, and this is not equal to. Reflex move when the target is not nothing. So basically, when you have something, you move. And here you say, what is the path to follow? The path to follow is myself going to the target. We have the target in the line here. And as I said, the target, and go on the graph. Yeah, not in space, but on the graph. Don't worry about this one, you can read through the tutorials. I'm just explaining the basic flow. You can ignore this one. Now it says if the target is location, that means you have reached your set location, the target, then your next target is nothing until your objective changes. Still with me? Yeah? So if you have a target, you move. You don't have a target, it's nil. And when you are resting, your target is nil. And this is a simple aspect. So a person is a circle, size 10. Be very careful. This is not a standard 5 or 10 or 25. If you are working at the scale of Rotterdam and you put 10, you will not see anything. Yeah, because Rotterdam is like 20 kilometer by 20 kilometer, and you say 10 meters, you will not see it. Although it might be the right size for a car, but you cannot see it. You will have to zoom in. So if you want to see, it's better make different sizes. Okay. Now we are in experiment. I will come to this little later. Let's look at output. So we defined different kinds of actions for agent, and something very important to understand is a reflex we defined in the species people is applicable to each agent. Yeah, you remember how reflex works inside a species? Is for every agent. And that is the beauty of agent-based modeling. You define behavior of one person and say the whole species behaves like this, so you're not programming everybody. And you define interaction between two species and is followed by everybody in the group. Okay, so now we have different species and their interactions, how they travel, when they travel, where they travel. Now it's time to have some display. So you say city display, type OpenGL for the fancy stuff. Species building, just the base aspect, roads, people. And you have a second display, yeah? Like you can have more than one aspect, you can have more than one species, you can have more than one reflex, you can have more than one action, you can have more than one display, you can have more than one chart. It just depends on the memory of the computer. Now, as I said, you look at this display, chart is refreshed only 10 cycles. So you usually don't want to do it every second or every step. It's just too much memory. Yeah, so this is a simple display. You are displaying the agents. Let's see. You see here city display. If I can open here. It's too
Large screens are better.
No, it's limited by the projector, not by.
Yes, I know.
I don't know if we could change it because it's too small for me.
No, it's great. I'm just saying at home. I have a 4K monitor.
Okay. Can you see the bottom line here? Display, city display. The name is this one.
Yeah.
Yeah. And you have buildings, roads, and people. So that's what you have here. Buildings, road, and the yellow are the people. Let's look at the next display is chart display, which is this one. So when you define a display, you get a tab. And based on different calculations, you have these charts. Let's run it. You see something happening because there is some interaction. And here you can see people's objective. Are they resting? Are they working? It seems we are in office time, so everybody is working. Nobody resting at this point of time. But we can see now nobody is working. Everybody is resting. So it's very dynamic. Yeah. Now let's see how this one is done, the chart. Yeah. Active. 4 o'clock.
Yeah,
Let's see. We call the chart again an object and the name.
it's the next one. The second chart you just showed us.
Okay. So the chart has a name and the pie chart. So the type is pie. You don't worry about this one. And this is a position within the display. So it says start at x0 and y half the screen or half the display. Yeah. Because the other half is taken by this one, the previous chart. So we are going to create a pie chart and the data is coming from people, count, everybody, where each objective is working. Do you follow? So the data for the pie from the series working is a value coming from people by counting those who have objective working.
But if they have the objective working, it doesn't have to mean that they are already at work.
Yeah, they are.
There might be travel time.
Yeah, they only travel when the objective is working.
No.
If you want to have people in the building, then you change it.
Because you could also say the amount of people that are in office buildings.
Yes, you can. But this one,
So working doesn't mean really working in this
Yeah.
case. It does mean
It means I
they are preoccupied with
yes,
traveling to or being absent.
yeah, only the objective.
Yeah.
You can make your own collection. So for you, you can
So
say,
this morning at 10 o'clock you were working.
Yeah.
7 a.m.
so you could say, if you want to have people in office, then you say data in office. It could be any name, by the way. Value people count if each in building of type office. Was it office or industrial? Industrial. Do you follow? I say it again. Data, people in workplace, value from the people count where each dot location is building type industrial. Yeah?
Yeah, and then if you do the same for the
Yes.
resting, then you might not have all the people in the graph because some people are traveling.
Yeah, it's possible.
You could also count those.
So in
It's
that,
not industrial and not at home.
yeah,
it's
and you say
residential.
not home, not moving, then it's work. So you put two conditions.
Moving can also be moving.
Yeah?
Or if someone is moving, then you
Yeah.
have to put that in.
But I think you begin to see the beauty of it. You can really know everything of those people once they're in your experiment.
And in no place it looks like programming. It's like a natural language.
I mean, every function, or basically function that you have here, there's like those 100 or 200 or 500 lines of Java code beneath it. And that's what this Michael was talking about when he programmed this in Java. Yeah, this chart would be at least tens of lines, but probably more.
Yeah.
So because this is really tailored to this domain, so to speak, you can be extremely concise and much more legible, much more easy to read.
Now, one of the questions you could have is how to make these charts and how do I know what chart exists. You can obviously go to Gamma website, but I think they have tutorials just for charts. Yeah, here. So if you don't know the syntax and you just don't want to do a pie chart, there's a series chart, radar chart, pie chart, long series, heat maps, distribution examples, bar charts. Yeah?
Monkey-do is often a very good approach. You see, this is something I like. You just copy the syntax, you just monkey around a little bit, it works, and you say, hey.
So I like I said in the morning, the first place to look for help is a model library. You will find everything. Especially if you are a beginner, most of the questions would be answered.
Do you ever search for a certain function, like chart with Control H?
Yeah, I mean you can, but first you have to know what kind of charts are available.
Yeah.
Now if I say bubble charts, there's no bubble charts. Then you type bubble and you get nothing. So you also need to know what exists.
But if you want a bubble chart, you can always get the data from Gamma.
Yes, and that's why I wanted to introduce you to R.
It's a nice bridge, and it's for cloth.
So is everyone happy with how this works? Then I just want to do a little bit of R. Then we close at 5-ish. Yeah? Okay, I think something missing is, you see these parameters?
Oh yeah, perfect, yeah.
This is very important. Okay, I see that the instructor is always at a loss.
Come on, guys. First, what do you want? These or these?
I have something.
Come on.
Yeah, not the Dutch ones.
Not the last one. You can have these. I can have them.
They don't want it.
No? Then I don't want those.
Let's see how is YouTube. Yeah, it's working.
It's not working. Peter Hogeveen is still pretending he's there.
3 people are watching, not just him. I don't know who they are.
One.
Ah, okay.
Oh.
Yeah, let's continue. Some fun part. So you see these parameters here. So when you have a model and when you run it, almost everything is fixed when you build the model. Basically, when you hit this run, it's like compiled, and everything compiled is fixed. You cannot change it. Now you want to change something during the simulation. You define them in parameters. And I wish I had a big screen, but this is how they come. Here you see parameter shapefile for, can you still see it? Shapefile for buildings. The next one is shapefile for roads. This is what is coming here. Yeah? And you can bring in your files. Yeah? Similarly, if you want to change the number of people, now I want 200 people, not 100. Yeah?
Can you also change it during runtime?
Yeah. No, before runtime.
Yeah.
Only some of them can be changed during runtime, like shape, color.
MATLAB can do it.
Hmm?
MATLAB can do it.
No,
Yes.
no. You have to hit the setup again.
No, you can, for example, change pair to gradient.
You can add them. You cannot. Also here, you can manually add them. In a running simulation, you say, I want to add 2 more at this and this
No,
location.
but you can say, for example, grass grows faster.
Sorry?
You can say, for example, grass grows faster or sheep die.
But for the same number of people.
Yes.
Yeah, this is number of people I'm talking about.
Oh, no. But I mean is the parameters
Yeah,
of the agents.
yeah, that is this the next one.
You can do that during.
Yeah.
Oh, I didn't know that.
Yeah. So you can change these, as we just discussed. Maybe in a few days you will realize the need to change during runtime, and then you have to use these parameters, and you get this interaction with the model. And you can either have a value or a slider like this. Yeah. So you can change them. You can reset them from what
How
is
do
in
you
you.
open this screen?
Is always there. It's just a bit smaller because I wanted to.
Maybe it's only there if you run the experiment.
Yeah. When you run the
I think that value can't be changed. I don't know why. When I try to change that manually,
yeah.
sometimes it keeps fixed. I think it may have something to do with the code.
No, you have to refresh it. Here. But that's not something you would want to do in the beginning. If you are doing it already, that's good. So basically when you run, you get this view and you can change, again, not all the parameters, not all of them. Yeah. What you have initialized, you cannot change them, but something like which is changing over time, I will show you here. There is an update. Maybe not in this experiment. Okay, again, Control H, update.
This is powerful stuff.
Okay, this is mine. Let's look at what comes with gamma. maybe tutorial traffic. You see here, you define a variable that can be updated.
Yes.
You can only have integer current hour and some value, but you add this extra facet. You see update colon. So these are updated during the simulation.
So
Okay.
I can change that.
You can,
I can.
yeah.
True. Because it was the only thing that bugged me that I could do in NetLow and I couldn't do in Gamma.
Well, I think it's not fully like NetLogo. As I say, only some of them can be changed. I cannot give you an exact distinction, but it's possible.
No, but this update is good stuff.
Yeah. Let's look at something you may not use, but I will still show you. It's really bad now. When you are in a simulation and you want to get something, okay. You want to inspect people, let's say 20. I hope it's right. Yeah. Remember we were going to select someone and right click and say inspect. That is okay if you have 4 or 5 agents, yeah? If you have hundreds of agents, you don't know where they are in the network. So you go to this console. Well, I think it's just corrupt because of the projector. If you do on your machines and you click the interactive console, let's keep it here. Now I want to inspect, it's simple, inspect road. I think the species is road. Yeah, road 23. Don't forget the semicolon. Oh. Is roads? Okay. Ah, sorry. And is road, right?
Yeah.
So you have it open here. Well, I have small windows, so I'm not going to maximize again and again.
4K.
So you can look at the attributes. And when the simulation is running, you have this changing. So all these yellow ones is just to quickly bring to your notice that they are changing during the simulation. Yeah? The non-yellow are, as you can see, they are static. And because it's a road, its location doesn't change.
Do you have an extra screen where you work mostly or not?
Let's see something more. You want to focus on something. I think it is focused on, we will see in a moment, people 20. Yeah. So this probably is 20, yeah? Let's see, one of them, yeah, this is 20. So you want the focus to be on this guy. And when you run the simulation, it will always be focused on this guy. Oh, it's too fast. Let's do it also. Oh.